So this lesson today is on multiplying and dividing rational expressions. We are still going to simplify. So we're still looking at simplifying our expression when we have multiplication. We want to simplify and we want to divide out any common factors. We also want to still factor first. So when we look at this one, for example, I want to reduce this as much as I can and just write what would be left as a fraction. So I don't know, there are different ways to do this. Not everybody has to do it in the same steps. But for example, if I have an m squared in the numerator and it's multiplication and an m in the denominator, even though it's in the second fraction, I know that those m's cancel and I would only be left with 1 in the numerator. As well, 2/4, that's the same thing as 1/2. So I might be left with 1/2. I don't know if that makes sense for you. I like to just kind of cancel it as much as I can. What I'm left with is m over 2 because everything else would cancel out. We did talk about restrictions though, so we're going to continue with that. Where, see this m here is no longer, it was in the denominator. The denominator can never equal 0. We can't divide by 0. So that m could have never been 0 at any time, because if it was, we would be dividing by 0, which can't happen. So we would still, even if it doesn't ask you to, it's good to get into this habit of stating that restriction. This next one is a little more complicated. Let's just look at the left side first. So 3/6 is the same thing as 1/2. And I have x to the third and x in the denominator, so I would have x squared in the numerator that would remain because this x would cancel out. This y would also cancel out, so I would still be left with a y in the numerator and a 2 in the denominator. So I just simplified that first one. That's not the only thing you can do, but it's maybe one way to kind of get into the habit. I feel like I'm still going to have 4/5 here because I can't simplify that. But I know there's one more x in the denominator than the numerator, and there's an extra y in the denominator than the numerator. So I'm canceling these out because I could cancel one out of the denominator as well. Then we see if we can do anything else. So because it's multiplication, I can also look diagonally and cancel out any terms. So see here, 4/2, that's the same thing as just 2. I have x squared here and x in the denominator over here, so that could cancel out. And then I have a y. Oh, the y's just cancel out completely. So I have a 2 left in the numerator and a 2x in the numerator and a 5 in the denominator. We did cancel out all of the variables from the denominator. So any x or y at any time, if they had been 0, we would have been dividing by 0. So we have to state that restriction. This one here, okay, I see not a lot that I can do vertically, but I really want to do this. 12 divided by 3 is just 4. And 10 divided by 5 is just 2. Horizontally, we can't eliminate anything there. We're going to end up with 8, I think, in the end. And notice this m plus 4 and this m plus 4 can also be canceled out diagonally. So what am I left with here? Looks like, ooh, I have an m and an m squared. So I could even cancel out those m's as well. So I have 4m in my first fraction, and then I only have a 2 left on the right side. So I guess I'd just end up with 8m. But I have canceled out this bracket, and I can see this was in the denominator, the m. So I'd have to state both of those restrictions for the denominator. So m cannot equal -4 or 0, because if that m was a 0, 3 times 0 would have given us 0 in the denominator. Division is a little bit different. So Division, there's a little bit more to it. I'm hoping you remember uh, that we always invert and multiply when we have fractions that are dividing. I would factor first if I could. So the numerator I can't factor the denominator. So I'm going to just write this. I'm going to rewrite the first fraction as it was, change this to multiplication, and now I'm going to put the 2 in the numerator and the 3b in the denominator. So division, a rule for fractions, is that you invert or flip the second fraction upside down and change it to multiplication. Once we have multiplication, we can vertically cancel out, and we can also diagonally cancel any terms out that we see. What do I see? I see 9 and 3. I could make that just 3. And 2 over 4, that's the same thing as 1/2. I don't see any a's and b's in the numerator or denominator that cancel out. So I'm left with 3a over 2b. I can see that b can't be 0. That was the only restriction that we had on a variable all the way through that. You can say where b can't equal 0 and state that restriction. Some teachers would expect that. I think it's maybe a good habit to get into, but you wouldn't lose marks if you didn't say that, because I can see that b can't equal 0 in your answer. Okay, so division. I see division, I factor if I can. There's nothing to factor here, so I'm just going to invert and multiply. And so I wrote this second fraction, I wrote down the reciprocal, flipped it upside down. Now, because it's multiplication, I can either cancel cancel diagonally or vertically. 4 over 8 is the same thing as 1/2. The d's cancel out completely. I have one extra c in the numerator than I do in the denominator. So those would cancel, and I'd be left with c over 2. On this side, 6 divided by 3 is 2. The d's completely cancel out, and I have an extra c in the denominator. So I guess I would have 2 over c. That's kind of interesting. That's the same thing as 2c over 2c. The c's cancel out and the 2's cancel out, so I'd be left with 1. But I've canceled out my variables, so where back here c and d could never equal 0 at any time. So c can't equal 0 and d can't equal 0. Part C, I don't see any factoring that I can do, so I'm going to invert and multiply. What I notice here, I have an a minus 5 and a 5 minus a. The 5 is positive and the a is negative there. I don't really like that because they don't match and I can't cancel them out. So guess what I could do? I could divide out a -1. So imagine I divide out by -1, so the 3 would actually become negative. And if I divided 5 by -1, I'd get -5. If I divided a by -1, I would get positive a. So I could actually manipulate this and divide this by a -1, divide out a common factor. It's not like I'm changing the expression, I'm just writing it in a different way. The reason I did that is so that these would now cancel, which I really like to do. What else do I see? Ooh, 3 over 3 cancels out. And also 4 divided by 2 is just 2. So I don't know if that's super complicated. Maybe it'd be easier to see that this is still 1 over a, -1 over a. And over here, I just have 2 times a plus 1. I could say over 1 if I like. So what happens there? Can I simplify any more? I don't think so. But I could multiply the numerators together. So imagine with multiplication, I multiply my numerator together and my denominator. A times 1 is just a. So that would be my simplified answer. I have to go back though and look at my restriction. What do I see? I see a cannot equal 5 for sure, because that was canceled out from the denominator. But something that we should have been looking at all along is that Look back here. That was in the denominator. In factored form, I actually had an a plus 1 in the denominator over here. So even though we flipped it so that that became the numerator, when it's a division question, so I'm putting a star beside this, a division question, I have to state my restrictions here in this denominator. I also have to state my restrictions from here. But then when I invert and multiply, this numerator actually became the denominator. So I need to state my restrictions from there as well. So I could see here that I canceled that out. So a can't equal 5. I also have to say that a can't equal 0. I know I see it here in my answer, but it's something that you could state. You don't have to state the 0. But the one I'm worried about is that this a can't equal -1. So these are the ones that you really have to state. So when you have a division question, you need to state restrictions. Once you're factored, once it's in factored form, you need restrictions from this denominator, this numerator, and this denominator. Because this denominator I know goes to the numerator, this is going to become a denominator. So if that makes any sense, that's the rule right there. You have 3 areas to state restrictions when it's division. Here's a multiplication question. So I'm going to have to state restrictions from here and from here once I factored though. So factored form first. So, oh my gosh, factor first. So what I see here is a complex trinomial, which I'm going to just do trial and error to get my answer. I see a common factor in the denominator of 6x, and I'd be left with x plus 3. I see a common factor in the numerator over here of 4x squared. I'd be left with 2x plus 1. And in the denominator, that's a difference of squares. So I take the square root, 2x plus 1, 2x minus 1. And it does help when you're factoring to say what they're called. Oh, there's a common factor. There's a difference of squares. This complex trinomial, I want to make the front give me 2x squared. And I want to make the back give me 3. 3 times 1 is 3. And then I want to make sure that the middle gives me positive 5. So what's this? This would be 2x plus 3x, which would be 5. But they both have to be positive to give me 5. And I get a -3. So I don't think that order works. Maybe I would try, let's see, can I try the 1 here and the 3 here? So what if the 1 was here and the 3 was here? That would be 6 and 1. So if I had 6 minus 1, I would end up with positive 5. So you just have to double check your factoring. I want to cancel out anything I can. I see those x plus 3's. I see a 2x minus 1 there and there. I see a 2x plus 1 in the numerator and denominator over there. I see this x cancels so that I would only have 1 left. And I even see this 4. If I divide by 2, I get 2. I divide 6 by 2 and I get 3. So I think I'm left with 2x over 3. You don't have to go that crazy all in one step. You could have just done the left side and the right side and then look and see if you had anything else you could cancel. But I'm going to just state my restrictions. X can't equal, I just need to worry about anything that was in either denominator. So x can't equal 0 from there. X can't equal -3. This also canceled out, so that x couldn't equal, okay, if you're not sure, remember you can always write it out. Solve this like an equation. Divide by 2. So x can't equal -1/2. And this one, if you're not sure what that is, remember 2x minus 1 can't equal 0. This time this would come over, it would be a positive. So divide by 2, x can't equal a half. So I would have to state all of those restrictions because I don't have any variables left in my denominator. So they've all canceled out and I need to state all the restrictions just from both denominators in factored form. Division, okay, remember division, I'm going to have to state restrictions from denominators and from this numerator. So we'll have to be careful there. I honestly just usually write this out. I don't try and do too much at once. I write this out and invert and multiply. So I like it better. It's all multiplication. I know that's a lot of writing. I see a complex trinomial in the numerator. I see a difference of squares in the denominator, both denominators, and another complex trinomial over here. So I'm going to do the easy part first. Square roots, 3x plus 2 and 3x minus 2. I don't know. I feel like I'm getting somewhere. 4x plus 1 and 4x minus 1. Okay, what do we have here? So we have to have two sets of brackets that make this work. I have to get 6 in the numerator, so let's try 2 times 3, 2x times 3x. And then I have to get 2 at the back, so that's pretty easy. We could just do 1 times 2 is 2. And then we check and see if we can get negative 7 in the middle. So the outside would be 4 and the inside would be 3. If they were both negative, I would get negative 7. So that wasn't bad. This one, I'm going to try and make the front give me 12x squared. Let's try 3x times 4x. That's 12x squared. Negative 2 in the back. So let's try 2 times 1. Then we check to see if we can get 5 in the middle. The outside was 3. Ooh, and the inside, oh, this is lucky today. The outside is 3 and the inside is 8. If the 8 was positive, and then I subtract the 3, I would get 5. So I double check it like that. I'm thinking of first, outside, inside, last. Yep, I get what I have up there, so I know what's correct. Now that it's multiplication, I can cancel terms out vertically or diagonally. What else? Oh, vertically over here. That's not bad. So in the numerator, I'm left with 2x minus 1. And in the denominator, I just can't go any further. I'm left with 4x plus 1. But I need to state my restrictions. So where, okay, I know x can't equal negative a quarter. And you'll get the hang of that. You can always write it out like this. And then move the 1 to the other side. And then divide by 4. I know it's going to become negative and I'm going to have to divide by 4. So I'm not super picky if you state that one. We know that it can't equal negative a quarter because I can see it in the answer. I'm going to look at my denominators here. So x can't equal negative 2/3 or positive 2/3. I'm going to look at the denominator here. Anything cancel out? Yep, 1/4. X can't equal a quarter because that canceled out right there. And then I also have to look at the numerator. X can't equal negative 2/3. Okay, so I already had that. And x can't equal 1/4, and I already have that. So don't forget, I have to look at restrictions because it was invert and multiply. I have to look at restrictions from the numerator, denominator, and this denominator.